Good morning, everyone. Hope everything is going well, and I hope you had a good weekend. Blank notes for today's lesson can be found on the Schoology page like normal. We are looking at an assessment on this stuff. Probably not this week, but next Thursday. So a few more days of notes, and then we'll assess on this next week. So today we're going to take a pause on new formulas and new equations, and we're going to look at some applications of parabolas and ellipses. Okay, I'm going to do two videos today. I'm going to start the first one with the application of parabolas, and then I'll pause it, and then I'll do applications of ellipses. Okay, so check out this first one. One cool thing about a parabola, one application we'll use a lot is this. Suppose an object is shaped like a paraboloid of revolution, a surface formed by rotating a parabola around its axis. So a paraboloid of revolution basically means if you take a cross-section cut of whatever object you're looking at, you'll see a parabola, right? So that's what we have right here. Think about a flashlight. If you cut a flashlight in half and look at it from the side, what you'd see is a parabola. So a flashlight is a paraboloid of revolution. So one cool thing about this is if any light, sound wave, radio wave, etc., any kind of wave is placed at the focus, right? So if this is the focus right there, the rays will reflect out in a line parallel to the axis of symmetry, right? So for this parabola, think about the flashlight, the axis of symmetry is right there. So any light light wave that shoots out from this source at the focus will hit the parabola, the paraboloid of revolution, and will shoot out parallel to the axis of symmetry, right? So any light, there's millions of them, right? Any ray that goes like that, even if it hits there, it will reflect out parallel to the axis of symmetry. So that's one of the reasons why a flashlight that has a little tiny light in it creates such a big light. They put a reflective material back here, and the light is multiplied, right? Every ray that comes out of there reflects back away from the flashlight parallel to the axis of symmetry. Now, it works the other way too. Any ray or wave to strike the surface of the paraboloid of revolution, these rays will be reflected to a single point at the focus. So anything coming in, think about a satellite dish. Cut that in half, that is a paraboloid of revolution. Cut that in half, you see a parabola. Any ray that comes in will hit this dish, and every ray will be focused on that focus. One of the reasons why that's called a focus. Even if the ray comes in like this, hits there, boom, it will reflect to the focus. So that's how satellite TVs works, right? So when you're building this thing, you have to make sure that this focus is at the best spot to get the best signal or the best reception. So if that thing breaks or gets skewed, you got to put it back in the right spot. All right, so let's practice a few problems dealing with this kind of stuff. You can see the answer down there. That's fine. It's just a sample sentence to explain everything. So example 1 here says a satellite dish is shaped like a paraboloid of revolution. Signals that emanate from a satellite in space strike the surface of the dish and reflect to a single point, that's the focus, where the receiver is located. If the dish is 8 feet across at the opening and 1 foot deep at the center, where should the receiver be placed? Okay, so for all of these applications, you get to decide this graph, right? You get to pick where everything goes. You get to pick where the center or where the vertex goes. Now, for most of the problems, not all, for most of the problems, it's easiest to make the center or the vertex, right? For ellipses, we have centers. For parabolas, we have vertices. So make the vertex at 0, 0. Most of the time, that is the easiest way to handle things. Now, all the time. Now, this is optional, too. You could put the vertex anywhere you want. But if you remember our equations, a vertex not at 0, 0 adds h's and k's into the equation. If we can avoid h's and k's, we have a much easier equation, right? So here's the cross section of this satellite dish. I'm putting the vertex at 0, 0. My h and k are 0, 0. Now, let's read what we know. We know it's 8 feet across at the opening. So this opening right here is 8 feet wide. That means it's going to be 4 feet to each side, so 4 feet that way and 4 feet that way. The reason that helps me is now I know the xy values, or at least the x values here at the tips. So because it's 8 feet across, That's going to be 4 comma something. And this point over here is going to be negative 4 comma something, right? Next thing we know, it says it's 1 foot deep at the center. So this is the center. We know this distance here is 1 foot. All right, so I know the height of these points is 1 and 1, right? So that's the setup of the picture. Now, here's what you have to be careful about. Nowhere in this problem does it say that the focus is going to be there, right? We don't know that the focus is going to be at 0, 1. Don't make that assumption. If you look back at this last picture, the focus does not have to line up with the depth of the dish, right? The focus can be higher than the depth of the dish. You could have a satellite like this where the focus is down here. So you can't just assume that the height of the dish or the height of the whatever paraboloid of revolution you're looking at is where the focus is going to go. Okay, so we can't assume 0, 1 is where the focus goes. But here's what we do know. Because of the way I drew this, and I drew this as a vertical parabola, you could have just as well drawn a horizontal parabola. But because I drew a vertical parabola with a vertex at 0, 0, I know this is the equation I'm dealing with. I'm going to do this in blue. I know I'm dealing with an x squared equals 4ay, right? Now, we practiced this skill in the previous lessons, in a previous lesson. Because I don't know anything about the a value, and that basically is what I'm trying to find, right? I'm finding where do I want these guys, the signal to focus is a code for asking where the focus should go. The a value is what takes me to the focus. So what I'm going to do now from using this equation is I'm going to plug in an x, y point so I can solve for a. Now you could use either one of these points, right? You got a negative 4, 1 or a 4, 1. I'm just going to use the positive numbers, 4 and 1. So plugging in x, 4 for x, I get 4 squared. For a, plugging in 1 for y, I get that. And if I solve for a, right, divide both sides by 4, I get an a value of 4. Now that's where I can stop for this problem. I don't need an equation. I don't need to do anything else. The question asked where to put the focus. And if I graph this, right, 4 comma, if I go up from my vertex, right there, if I go up 4 units, my focus is going to be somewhere up here, right? There's the focus at 0, 4. It's going to be off the graph a little bit. And that's why I have the sentence worded the way I do. Place a receiver 4 feet above the base on the axis of symmetry, right? So for this problem, all I had to do was find the a value, and that was the key to know where the focus goes. That's it. Okay, let's go another one. So this is another application of parabolas. It says the cables for an experimental model of a suspension bridge are built in the shape of a parabolic arch. So I think looking at this picture, it's pretty obvious to see you got parabolas here. Think about the Golden Gate Bridge or one of these other suspension bridges out there. This says the towers are both 5 inches tall from the roadway and stand 60 inches apart. Find the vertical distance from the roadway to the cable at a point on the road 10 inches from the lowest point of the cable. Okay, so a little wordy here. Might have to read it once or twice to kind of figure out what's going on. But here's what we're looking at. This is our parabola right here. All right, so this is the side view of the bridge. You can see the parabola. Now, again, you get to pick where you put that parabola. I'm always going to put that vertex right there at 0, 0. So here's my y-axis, right? And my x-axis is the roadway. To me, that's the easiest way to handle this problem. All right, so I got a roadway here at, I'm just going to make the roadway's the x value, the x-axis, and here's my y. So y-axis there, x-axis is the roadway. Okay, now we got to kind of decode and get some hints here what it's telling us. It says the towers are both 5 inches tall from the roadway. So because the x-axis is my roadway, if I know go to this point right here, I know the y value of that point is 5. I also know over here that the y value is 5, and I'll show you both points, but like we saw in the last problem, we really are only going to need usually 1 point on the parabola. It also says that the tower stands 60 inches apart. So very similar to the last one, was 8 feet across. So we went 4 each way. This is 60 inches apart, so we're going to go 30 each way. So this point is 35, 5, and this point is negative 30, comma 5. So that's how I got these two tip-top points, right? Now it says, find the vertical distance from the roadway to the cable at a point on the road 10 inches from the lowest point on the cable. Okay, so the lowest point on the cable is right here at the origin. And I want to find the vertical distance from the roadway up to the cable. So let's say 10 inches from the center, or 10 inches from the lowest point. So let's say we go this way 10 inches, right? Maybe right about there. That is really going to be the x value, right? If I go 10 to the right, that's the x. I want to know the vertical distance. So the vertical distance is another way of saying, what is the height? So what I'm really looking for here is I'm looking for the coordinates of this black point. I know the x value is 10 because, again, I went 10 inches from the lowest point, which is the origin, and I'm looking for the y, right? And that's the setup. Now, in order to solve this problem, I need an equation. Unlike the last example where I stopped when I got the a value, for this one I'm going to have to go a little bit further. So, because of the way I drew this parabola, it's another x squared equals 4ay. Because I put the vertex at 0, 0, I don't need an h and a k. And just like the last problem, I can find the a value. I'm going to again use this point here. So I'm going to plug in 30 for x. I'm going to plug in 5 for y. And I end up getting 900 equals 20a. I divide both sides by 20, I get an a value of 45. Okay, now I can't stop there. This problem doesn't say anything about the focus. But what I can do using that 45 is come up with an equation. So x squared equals 4 times a times y. The a value from the last page is 45, right? That was our a, so I get to plug that in. That gives me an equation for the parabola of x squared equals 180y, right? That's my equation. Now, to answer the question, I want to know the y value when x is 10. So this equation I have right here, x squared equals 180y, describes this parabola I just drew there, right? The one from the bridge. So now to find the y value when x is 10, I'm going to plug in 10 for x. So when x equals 10, you get 10 squared equals 180y. So we get 100 equals 180y. Divide both sides by 180 and reduce it. You get 5/9. Now that's an exact answer, but for this problem, it's good to get a decimal approximation. That rounds to 0.56, and we're talking about inches in this problem. Right? So at a distance 10 inches from the lowest point, 10 inches this way, the height of this cable is 0.56 inches off the roadway. Yeah. All right. So that is those are two good examples of parabolas. I'm going to break the video up a little today, and my next video will be on